Okay, so in this video, we're going to start chapter 6, which is going to be a study of the contrapositive. And we've seen the contrapositive in the chapter on logic, but we didn't see how to use it as a proof technique. So that's what we're going to do here. But let me just first remind you of what the contrapositive is. So we'll start with a theorem which says that, and we'll say it in words first. So an implication is logically equivalent to its contrapositive and then in symbols, that's like saying if P implies Q is logically equivalent to not Q implies not P. Okay, good. So now we're going to see how to use this as a proof technique. But before we do that, we should just practice converting implications into their contrapositive to make sure we understand how to do that. So here we'll do a sequence of examples like that. So let's say that for the first example, P implies Q is the statement if n equals 6, then n is even. We know that that's true, so we should see the contrapositive also being true. So the contrapositive says that, oh, this should have been if, not in. So this says if n is not even, then n is not equal to 6. And that's also true, right? Okay, great. That's our first example. Let's keep going. So now, let's do one purely in words. If I just dumped water on you, then you are wet. Okay, and then this is the kind of implication you'll study in logic for philosophy, but we can still do that here. So then the contrapositive would be if you are not wet, then I did not just dump water on you. Okay, simple enough. Let's look at some other examples that are more math focused. By the way, I'm not sure if I mentioned this yet, but logic is very much used in philosophy as well, and you'll study this kind of formal logic, and there you'll see statements like the one we just did. But for mathematics, we often have certain kinds of statements we want to make about mathematics. So for instance, if P divides A times B, then P divides A, or P divides B. Okay, now we're going to knot this. Well, we're going to find its contrapositive, which is going to involve knotting the Q and knotting the P. Here we have to be careful because the Q here is the statement P divides A or P divides Q. So when we P divides V. So when we knot this, we're going to hit the knot's going to hit both of the expressions and the or is going to become an and, right? So the contrapositive is if P does not divide A and P does not divide B, then P does not divide the product, right? So that's very important to make sure that the that they're equivalent statements, that you take care of the or properly when you not it so that it's equivalent, right? So now they are equivalent, but if you messed up part of that, you would get something that is not logically equivalent, and that would kind of cause problems. Okay, so let's do a few more. So if m times n is odd, then m is odd and n is odd. So again, here the Q is an and in it. So when we go to calculate the contrapositive, we'll have to take care of that properly. So now it should be if m is not odd or n is not odd, then m times n is not odd. Now, notice that not odd is the same thing as even. So I could also choose to write this more, perhaps if it'd be sound a little bit better if I say if m is even or n is even, then m times n is even. So all these things are logically equivalent, right? I'm just using the fact that not odd is the same thing as even here. And so we get something equivalent. Okay, let's just write down one more example. So if n squared minus 4n plus 7 is even, then n is odd is the implication. And then the contrapositive is if. Again, it could be if n is not odd, let's just write that as n is even, then n squared minus 4n plus 7 is not even or odd, right? Now, again, we could go through all these and figure out whether they're true or not, but whether or not the implication is true is not even exactly what we're focused on. Instead, what we're focused on is the fact that the implication and its contrapositive are logically equivalent. So if one is true, the other one's true. If one is false, the other one is false, right? That's what's important. And in the following videos, we're going to see how to use the contrapositive as a proof technique. Let me just say it now in words, is that the proof technique is the following, that sometimes when you write down the implication, you are inspired with a different idea of how to prove things, or not even just inspired, but perhaps there is a more advantageous method available to you when you look at the contrapositive. And that's the method. It's just that sometimes it's easier to prove the contrapositive than it is the regular implication. Since they're logically equivalent, if it's easier to prove the contrapositive, then you should, right? And you'll have proved the implication anyway. So we'll see that in the next video.